everyone, and welcome to the first chapter of our Chemistry O-Level Lessons series. This chapter is called Experimental Chemistry. Here we have the learning objectives of this chapter, and all the topics of this chapter are listed in the description below, along with their chapters. So, in this chapter, we are going to learn to name appropriate apparatus for measurement of mass, volume, time, and temperature. We're going to learn to state the unit for measuring mass, volume, time, and temperature, and suggest a suitable piece of apparatus for measuring, depending on the accuracy required. So, the learning objectives. We're going to learn to suggest an apparatus giving relevant information for the collection of a particular gas, and lastly, how we can deduce that a chemical reaction can be followed by either collecting a gas or recording a loss of mass as the gas escapes. So, basically, what are the apparatuses we use for measuring mass, volume, time, and temperature of either gas or liquid or solid? How we can record the change in mass or the change in volume. We're going to learn the units for measuring mass, volume, time, and temperature. We're going to learn to name appropriate apparatus for measurement of these physical quantities. We're going to learn to suggest a suitable piece of apparatus for measuring depending on the accuracy required. So these are the learning objectives in this course. So without further ado, let's get into it right away. So, experimental chemistry. Firstly, we're going to learn about measurement, mass, volume, time, and temperature. So, chemistry is a science, and like all sciences, it involves the measurement of various quantities. Often we need to measure accurately amounts of chemicals, perhaps solids, for example powders and crystals, liquids, for example acids, alkalis, solutions, or gases. Amounts of solids are usually measured in mass, and amounts of liquids and gases in volume. So, to follow different chemical changes, we might follow changes in mass or volume with time. And all chemical changes involve energy changes as well. So you should remember that. Often, this energy change is a heat change, which can be followed by recording changes in temperature. So this was the introduction to this chapter, measurement. Now we're going to start our first physical quantity, mass. So, this is the definition of mass here. The mass of a substance is the amount of matter it contains. It's very simple, right? The mass of a substance is the amount of matter it contains. In chemistry, we need to measure mass more accurately than everyday way of measuring it, in terms of amounts such as a pinch of salt or a spoonful of sugar. We use balances to measure mass accurately. So the two common types of balances we use to measure mass in school laboratories are the beam balance and the electronic balance. These electronic balances are now usually in our homes as well to measure different ingredients. Like for example, when we're baking a cake, if the recipe is given in grams, kilograms, and stuff like that, like the unit of mass, then we use a weighing scale or electronic balance, in other words, because in cakes and such recipes we need to be very accurate. So that is why we use the balances. They are the most accurate, even accurate than the measuring cups we use to measure ingredients. Anyways, in a beam balance, a weight is moved along this horizontal scale until it balances the mass of an object on this scale pan here. But electronic balances are far easier to use and can measure accurately to 0.01 grams or even 0.001 grams very quickly. All you have to do is place the thing that you want to measure the mass of and it'll give you the reading. No need to do the stuff of balancing two masses. Okay, so the unit of mass is the gram. The gram is represented by a small g. So we use grams for small amounts of mass, and the kilograms for larger amounts. kg is the symbol for kilograms. So this was all about mass. The instruments we use to measure mass, the beam balance and the electronic balance, the definition of mass, and the unit of mass. I hope you're going to remember this, as it's very important to remember all these definitions and the units, because we're going to be using these in the upcoming chapters of this series a lot. So now we're going to move ahead onto the volume. This is another physical quantity. Here we have the definition of volume. So the volume of a substance is the amount of space it occupies. Again, very simple. Mass of a substance is the amount of matter it contains. The volume of a substance is the amount of space that substance occupies. Volume is usually measured in cubic centimeters, also called the centimeter cube. This is the symbol for centimeter cubes, cm cube, okay. Though larger volumes may be in cubic decimeters, the decimeter cube. This is written as dm cube, or liters. A liter is represented by a small l. So cubic centimeters is the unit of volume. Then we use cubic decimeters or liters for larger volumes. So in the laboratory, volume can be measured in various ways. Approximate volumes of liquids can be measured in a graduated beaker. This is what a beaker looks like. And with a beaker, we can measure approximate volumes of liquids. Okay? But for greater accuracy, a measuring cylinder can be used. This is the measuring cylinder here, as you can see. It's longer and thinner than the graduated beaker. But for even more accurate measurements, a pipette or burette can be used. This is the pipette and this is the burette. They're even thinner than this measuring cylinder. A volumetric flask, as you can see here, is used to measure fixed volumes of liquid and is used for preparing solutions of known concentration. So, for volume, we have different instruments that can measure the liquid with different accuracies. Graduated beaker measures approximate volumes of liquids. That means that it doesn't have that much accuracy. The volume of the liquid can only be approximate. Then we have the measuring cylinder, which is a very accurate measuring device. But for even more accurate measurements, a pipette or burette is used. A volumetric flask is far more different from all these. This is used to measure fixed volumes of liquid. Okay, and it is also used for preparing solutions of known concentration. So with a volumetric flask, everything is fixed, known and fixed. Okay, now let me tell you some more details on the accuracy of these instruments. So the beaker, as we all know, measures approximate volume. The measuring cylinder here is more accurate than the beaker, but how much accurate? You should remember this. A measuring cylinder is accurate to the nearest centimeter cube. Okay, so a measuring cylinder is accurate to the nearest centimeter cube. This is the accuracy of the measuring cylinder. A burette, like this, is accurate to the nearest 0.1 centimeter cube. And so that suggests that it is even more accurate than the measuring cylinder. So the volume of liquid required is run off from the bottom through this tap. So remember, the accuracy of burette is to the nearest 0.1 centimeter cube. A pipette, as you can see, like a volumetric flask, a pipette measures fixed volumes. For example, 25 centimeter cube, 50 centimeter cube, 10 centimeter cube, very accurate, 10 centimeter cube. So the pipette measures fixed volumes very accurately. A volumetric flask measures fixed volumes as well, but it is usually used when making up solutions of exact concentrations. Fixed volumes like 100 centimeter cube, 250 centimeter cube, and 1 dm cube. But so when measuring the volume of a liquid, it is important to read the volume at the bottom of the meniscus. So this is the bottom of the curved surface of the liquid in the container. Remember, whenever you see the liquid, it's kind of curved, okay? So whenever we read the volume, we always read it at the bottom of the curved surface of the liquid. And this is called the meniscus. So volumes can also be measured using syringes. Small plastic syringes are used for measuring small volumes of liquid. Such syringes are used by doctors for injections. You've seen that, of course. Whereas larger syringes are used to measure the volumes of gases. A gas syringe is usually made of glass. Okay? So, to measure volume, we have many different instruments. And all of these instruments have their own accuracy of measuring volume. And to measure mass, we have the electronic balance. So this was it for the volume as well. Remember this definition, the unit of volume, and these instruments here. Now let's move ahead on to time. So in the laboratory, time is measured using a stopwatch or a stop clock. And as we all know, it is measured in seconds. So most stop clocks measure timing to the nearest second. But there are also very accurate stopwatches that can measure to 0.01 seconds. That is the 100th of a second. So that's very accurate. So for time, it's very simple. Stopwatches, stop clocks. This is what we use to measure time. Then we have temperature. The temperature of a liquid or gas can be measured using a thermometer. So the unit for temperature is the degree Celsius. This is the symbol for degree Celsius. The mercury in glass thermometer and the alcohol in glass thermometer are common thermometers which are used in the laboratory. But nowadays electronic thermometers are increasingly being used as they reduce the risk of mercury poisoning if a mercury thermometer is broken while in use. You can see this mercury here. Tiny droplets of mercury all around. And these droplets are extremely dangerous. They're very poisonous. So that is why electronic thermometers are being used. Again, there's not much stuff about temperature as well. Just the degree Celsius and the thermometers is all you need to know. Do you know that temperature sensors or probes can record the temperature of a liquid over a period of time? Such results can then be fed into a computer and displayed as a graph of temperature against time. So, devices which can capture the experimental data in this way are known as data loggers. So, here is the table of what we just learned here. What to measure, the units, and the measuring device. So, we have mass. The units of mass are the milligrams, grams, and kilograms. The gram is the actual unit. Then to measure smaller masses, we use the milligrams. And to measure bigger masses, we use kilograms. So 1000 milligrams make up 1 gram. And 1000 grams make up 1 kilogram. And 1000 kilograms make up 1 ton. Okay? So the measuring device we use to measure mass are the beam balance and the electronic balance. So then we have volume. Units of volume are the cubic centimeters. 1000 cubic centimeters make 1 cubic decimeter. 1 cubic decimeter is equal to 1 liter as well. So 1 decimeter, 1 cubic decimeter is also equal to 1 liter. But 1000 cubic decimeters are equal to 1 cubic meter. So these were the units of volume. The measuring devices for volume are the beaker, the measuring cylinder, the pipette, burette, volumetric flask, and syringes. Then we have time. The units of time are the seconds, the minutes, and the hour. 60 seconds are equal to 1 minute, and 3600 seconds are equal to 1 hour. And 60 minutes are also equal to 1 hour. And the measuring device we use to measure time is the stopwatch or the stop clock. Then lastly we have the temperature. The unit for temperature is the degree Celsius. Very simple. We also have Kelvin, but more commonly the degree Celsius is used. The measuring device for temperature are the mercury in glass thermometer, the alcohol in glass thermometer, still almost the same thing, and the electronic thermometer. So this was it for the units and the measuring devices of these 4 things: the mass, the volume, the time, and the temperature. So now that we've covered the mass, volume, time, and temperature, and all the different things we needed to know about them, all given in this table, we are going to move ahead on to understanding the collection of gases. How we collect gases. So, the collection of a gas depends on whether the gas is heavier or lighter than air, and also if the gas is soluble or insoluble in water. So many gases are colorless and can only be seen if bubbled through water and trapped above the water's surface. However, if a gas is soluble in water, this method of collection cannot be used, okay? Because it will simply just get absorbed in the water. No bubbles will be formed. If it's insoluble, only then the bubbles will form. Here we have a table again that shows the density and the solubility of various common gases. So, gases. Here we have the common gases. You're going to read about these gases quite a lot in these lessons. First, we have ammonia. Ammonia is a colorless gas, and its density compared to air is lighter than air, I mean. The solubility in water, well, it's extremely soluble. Then we have carbon dioxide. This is also a colorless gas, but unlike ammonia, it is heavier than air, and it is only slightly soluble, whereas ammonia is extremely soluble. Then we have chlorine, which is green/yellow in color, greenish yellowish in color, and it is much heavier than air. As for the solubility, it is soluble, a normal soluble. Carbon dioxide is slightly soluble, but chlorine is soluble, okay? You get the point. Then we have hydrogen. This is a colorless gas, again, and it is much lighter. As for the solubility, hydrogen is insoluble in water. Then we have hydrogen chloride. Hydrogen chloride is also a colorless gas, and it is slightly heavier than air, not very much. It is very soluble in water. And lastly, we have oxygen, which is a colorless gas again, and the density of oxygen is about the same to the air, to the density of the air. It's like almost equal. As for the solubility, the oxygen is slightly soluble. So, again, memorize this diagram here as it's very important in the upcoming chapters. You know why we need to know all these properties of gases? To know how we can collect these gases. If we do not know the properties of the gases, which method are we going to use on the gas? We wouldn't know that as well. Because some gases are very soluble in water, some gases are not very soluble in water. Some gases are heavier than air, lighter than air, and air and water are quite a lot used to collect gases. So each gas would be collected in a very different way. So we need to learn the properties, memorize these properties as well. So gases which are heavier than air, like hydrogen and ammonia, can be collected by upward delivery or downward displacement of air. And gases which are heavier than air, like carbon dioxide and chlorine, can be collected by downward delivery or upward displacement of air. So here we have the methods for the collection of gases. Here's what we're talking about. Because heavy gases fall down, like they come down, that is why we use the downward delivery upward displacement method. What happens is that the gas goes downwards, it's a downward delivery of the gas, and an upward displacement of air. That means that the air is pushed upwards. The air is displaced upwards. Okay, so this is the collection of a heavy gas. The collection of a light gas is the total opposite. Here we turn the cylinder upside down because the gas rises up rather than sinking down. It rises up. So this would be an upward delivery and downward displacement of air. The air is displaced downwards because the gas is lighter than air, so it will displace it. Okay, now here we have the collection of an insoluble gas. This insoluble gas over water. Because it is insoluble in water, we can pass the gas through water, and as it would be colorless, we wouldn't be able to see the color, but we would still be able to see the bubbles. These bubbles will indicate the presence of an insoluble gas. And so, after passing through water, it would be collected up here. But of course, this method would not work if the gas is soluble in water, as it would just be absorbed over here. Here we have a small apparatus for the collection of gases. Here we have dilute hydrochloric acid plus marble chips, which are producing a light gas. Okay, so the gas is passed from this delivery tube, and because it is light, it rises up, goes here, and then goes here, and comes into this water. Then again, as it is a light, then Again, as it is a light gas, it moves upwards, and of course it needs to be insoluble in water. It will move upwards and get collected over here. So we produce the gas through dilute hydrochloric acid and marble chips, and we collected it this way. But remember, we don't pass a gas from water without any reason. I mean, of course, it's not just water that is here. It is also sulfuric acid. So sulfuric acid, of course, it contains water. So we still cannot pass a soluble gas through the sulfuric acid because it will again get absorbed in it. But why do we use the sulfuric acid? Why do we need to pass the gas through sulfuric acid and then collect it? Because we need to dry the gas. Sulfuric acid dries the gas. So that is why after producing the gas, we need to dry it first through sulfuric acid. It will pass through sulfuric acid and then it will get collected on top in this measuring cylinder. This here, in which this liquid is stored and the measuring cylinder is inverted, this is called the trough. Here we have the clamp which holds the measuring cylinder. Of course, the measuring cylinder is not just put inside, otherwise the gas would not be able to come inside. So that is why we have a clamp that holds the measuring cylinder upwards. And we have some space over here. So this is how we collect gases. The upward delivery and the downward delivery collection of insoluble gas over water. I hope you've understood this. Also, I hope you're going to memorize this entire table of gases and their properties. So we are going to move ahead on how we can measure the speed of a chemical reaction. So we can measure the speed of a chemical reaction where a gas is given off by either collecting the gas over a certain time interval or recording the progressive loss in mass as the gas escapes into the air. Okay, so the speed of a chemical reaction. How fast or how slow the chemical reaction is taking place. We can either do this by collecting the gas given off over a certain time interval. That is how we can measure the rate of the chemical reaction, or in other words, the speed of the chemical reaction. Or we can also record the progressive loss in mass as the gas escapes into the air. Okay, a convenient method of collecting a gas, especially a water-soluble gas, is by using a gas syringe. Well, it's pretty simple. Here we have a flask which contains some chemicals. All we do is place this gas syringe through this. As this gas is going to be light, it will move upwards and go into this gas syringe. So as the gas would be given off, the plunger would be moved forward, like it will be pushed outwards as the gas would fill up in this syringe. So we will measure the time taken for a specific amount of gas being measured. How much amount of gas is being measured in 1 second or in 10 seconds, 5 seconds, like that. And so through that, we're going to get an approximate speed of the chemical reaction taking place. How fast is this? What is the rate of this chemical reaction? Okay? This is one way. This is one convenient method of collecting gas, especially if it is a water-soluble gas. The other method is by recording the mass, measuring the loss of mass as a gas forms. So here we have a reaction mixture, and as these chemicals turn into a gas, there is a decrease in mass. So we place this flask with the reaction mixture over a balance, an electronic balance. We have a cotton wool so that only gas can escape. So what happens is that this reaction mixture, as the gas would form, it will escape through this volumetric flask, and so there would be a decrease in mass. So then we record the mass every 30 or 60 seconds, and through that we will be able to record the change of mass at fixed time intervals, and we will get to know the speed or the rate of the chemical reaction. So these were the two methods, the mass method and the volume method, by measuring the increase in volume or by measuring the loss of mass. So this was it for today's chapter. I hope you've understood how we can measure the rate of reaction and how we can collect gases, different types of gases and the different methods to collect them. mass, volume, time and temperature, their units and their measuring devices. I hope you're going to memorize all of this stuff as well. So that was it for today's chapter, Experimental Chemistry. This was our first chapter, and after this chapter, we're going to have a second chapter which is going to be Particles of Matter. So thanks for watching this video, and I'll see you in the next chapter.